Welcome along, everyone. Thanks for joining us today. We'll give it a couple of minutes just to ensure some other people can join, and then we'll get started because there's lots we want to talk about. We've only got an hour, so yeah. More and more people arriving. Welcome along. Just give it till about 2-3 minutes past, and we'll get going. Maybe we'll get started. Still people joining, but that's okay. So yeah, welcome everybody, and thanks for joining us to today's webinar from AI Tools to Delivery Impact. Before we begin, I'd like to acknowledge the traditional owners of the lands on which we meet today. I'm joining you from the lands of the Wurundjeri people of the Kulin Nation, and I pay my respects to elders past and present, and I extend that respect to the traditional owners of all the lands our attendees and our speakers are joining from across Australia, and to any Aboriginal and Torres Strait Islanders peoples with us today. So a few housekeeping items to begin with. Today's session is being recorded. We'll ensure that you get the recording afterwards, along with any follow-up materials that might be relevant. If you like our slide deck as well, that's fine. Happy to send that across to everyone. Please add questions in the Q&A panel at any point. We're going to try and leave as much time as possible towards the end to answer those. Any that we don't answer, we'll be able to follow up afterwards as well. I'll introduce what we're talking about, introduce you to Serge and Rahul, who are our speakers today. And then, we'll get into 5 key questions for today that we want to tackle. So who am I joined with today? We've got Serge, who's a principal consultant at Dias. I believe it was 14 years in April, Serge, that you've been with us.
14 years, Chris.
Yeah, so there you go. Lots of tools and trends have come and gone during that time. But it's fair to say Serge's recent focus has been on AI-powered engineering, so what Dias's approach is towards that and how we tackle specific problems, so legacy modernization, greenfield builds, design systems, lots of different applications. And then we also have Rahul, who's a software engineering consultant at Dias, a relative newbie compared to Serge's tenure here, but straight into client engagement here at Dias with an organization we've been working for 8 years, and fair to say flying the flag for AI-powered engineering on the ground, not just adopting the tools, but the best way to go about it. So thanks, guys, for joining me today. Lots to share, lots to get into. I wanted to set the scene a little bit about what we've been hearing across the market when it comes to AI, and again, changing all the time, but probably a noticeable shift as to where the focus of people's minds are at. So 2 years ago, it was probably just help us start. Then it moved on to what tools are you using, what models, etc. Now it's very different, and it's okay, how are we using AI for engineering and delivery? And on top of that, how can we demonstrate value? And don't worry if you can't answer that second point, because not many can. And that's what a lot are getting tripped up on. So what comes into that as well is cost. And it's, the spend of AI used to hide inside experiments. Now engineers are using these tools on a daily basis. They're running agent workflows for hours on end. It's a real line item now, and something we need to be aware of. There's some stats there from a AWS AI First forum. Hot topic of conversation. Boards are asking, well, not only are we doing enough with AI, but are we kind of keeping track on things, and are we getting value back? So that's where we're at. We're pivoted. How do we scale the value of AI without operating costs, inconsistencies, governance, overhead, scaling faster than that? So value is real, proof is rare, but cost is now very, very, very visible. But we'll lean into Serge and Rahul for their thoughts on all those three. And just as another way of framing today's conversation, we know plenty of organizations are rolling out AI in their engineering and delivery practices, but adoption of an AI DLC means wildly different things depending on who you talk to. So one engineer could be just using a Copilot license and using it as a coding assistant. Others could be, having agents building features overnight and just reviewing at the edges. So while two are, say, adopting an AI DLC, they're years apart in terms of maturity. So at DS, we use Dan Shapiro's AI framework as a kind of a benchmark of where you're at in terms of AI maturity. I recommend you go check that out. But for now, I wanted to kind of step through these different terms, almost like a ladder of where you can take AI engineering. And if I can, I'll pass over to Serge to just walk through these different terms and what they mean and how they layer on top of each other.
Hi, folks. Thanks for coming along today. We really do appreciate it. We'd love to see you. Just very quickly going through these, there's not quite corresponding to the various stages of maturity for AI engineering, but nonetheless, three very important concepts to understand, especially when you're moving towards an overall structured approach to engineering across teams. So there's context engineering, which is structuring your knowledge and documentation in such a way as to make it consumable and useful for AI agents as well as other engineers. So that's product glossary, technical principles, product documentation, domain-specific language. It's a knowledge layer that allows everything built on it to operate correctly. Second layer that we'd like to talk about is harness engineering. So that's all the tooling that we build around and on top of that context. So skills, checks, CI hooks, most of it agentic, some of it deterministic, however. In this layer, the human is still the orchestrator of every step. So you might have a specification step, a planning step, an implementation step. It's the human moving and manipulating the agents through those stages. And then on top of both context engineering and harness engineering is the idea of loop engineering. Now, at this point, what we're doing is we are creating agentic workflows that are, to a large extent, autonomous. So again, they sit on top of the tools built in the harness engineering stage. They sit on top of the context created and organized in the context engineering phase. But they use these tools in this context to drive out product features from end to end, starting from a prompt or a vague idea all the way through to production or near production. So that orchestration responsibility is no longer taken up by humans. It's taken up by a agentic orchestrator for the entire process. Human judgment is still applied at the start and at the end. And those judgments are then fed back into the loop implementation. But the agents as a whole are far more autonomous than they are in the harness engineering phase.
Awesome. Thank you, Serge. Appreciate it. So as for the questions that we want to tackle, 5 broad questions for Serge and Rahul. We've tried to split them up into questions about people, about knowledge, about cost, risk, and proof. We'll try and answer each one in a roughly 5 minutes each. And then around the 40-minute mark, we're hoping that that's when we can pass over to any questions that you have, and we'll open the floor to our audience. So yeah, let's get stuck into that first one. How do you standardize a way of working so delivery isn't dependent on who's driving? So in conversations with the clients we work with and the people in our community and network, it's clear that there are engineers out there who are doing great things with AI and getting extraordinary results. But the problem comes when the members of their team or other parts of the organization can't reproduce those results. The copied prompts have quietly diverged across teams, and then if that leader leaves or resigns, the capability goes with them. And it's a common pattern we see in engineering, and we've seen it with legacy systems of years gone by as well. So individual kind of power users, it's not a failure. If anything, it's a good thing that they're managing to extract so much from the tools, but it's difficult to scale when you've got that model and it doesn't survive turnover, things like that. So maybe I'll go to Rahul first, and how can we go and standardize approaches towards AI engineering that means there's the benefit for everyone?
Yeah, thanks, Chris. I think a part of it is just understanding that the current kind of paradigm of AI, these are language models after all. So the good thing is we can connect these agents with human English language, wherever these documents live within the organization, whether it's Confluence or any other internal docs. And then a part of, I'd say, standardizing it really is not relying heavily on human written prompts. So what I mean by that is, like, instead of saying, okay, here's this draft of a prompt, which is just English, and sharing that across the team, that could work. That's one iteration. But I think now we've moved on to a point where we've got MCP servers, we've got a variety of other tools we can use where we enable the agent to go look up things in proper domains of the business or the org. And on top of that, to use like a solid example, in the current client we're working with, we have an internal agent that kind of acts like let's call it a product manager, where when engineers are working on a feature, they could refer to that agent to get context on the org or the product, so as to not having to like randomly prompt chatbots or whatever, which can be a little bit subjective one depending on how you prompt it. And then, yeah, as this suggests, for sure, using a proper framework. Like, for instance, I think the most popular one is probably SpecKit for coding agents. But there are heaps. There's OpenSpec. There's Claude's got their Superpowers plugin. But the TLDR would be not relying too much on humans or engineers, whoever it may be, writing their own prompts, but rather enabling the agents to talk to each other and talk to the other tools within the organization.
Awesome. Thanks, Rahul. Any further thoughts on that one, Serge?
Absolutely. I think Rahul's really hit the nail on the head there. A lot of the things that would have been previously, like previous years or previous months, up to the prompt to specify, and engineers would have varying degrees of skill at creating and crafting a prompt that would actually do what they wanted it to do. We've now abstracted into skills that are versioned and available to the entire agentic process, and those prompts are then processed in the context of those skills and by those skills. Those skills, as Rahul said, also have access to data sources, the appropriate data sources via MCP or via documentation or repositories. What we're trying to get at is that essentially we want to remove variation. So different engineers having different degrees of skill in crafting a prompt, we want that to not matter as much, because all of the domain knowledge or the technical knowledge is applied by the system via these version skills and this context that we've created around it. And that's what we really need to get to in order to have a process that we can rely on, a process that can be predictable.
100%. I think that's alongside cost, it's inconsistency that just keeps coming up again and again.
Look, the agentic LLMs are essentially inherently non-deterministic processes. So how do we harness those inherently non-deterministic processes so that we repeatedly and predictably get the results that we want? And that's the problem we're facing nowadays.
Yeah, and I'd say a shared pattern that the team owns beats something brilliant that nobody else can reproduce, right?
And one of the most important things here is that's a versioned shared pattern that the team can improve and build upon over time.
And I'd also say this has been the goal of a lot of software engineering even before AI. I mean, we got like design patterns, and we have, we use things like prototypes and whatnot, which is like it's a way to communicate sort of a shared contract with the rest of an org. And so it's in many ways, with introducing these stochastic models or non-deterministic models, it only becomes more important to pay attention to the importance of consistency of information across an organization.
Yeah, 100%. So some of the threads that we try and pull on at DIS, as you can see, picking those patterns, standardizing them, using STD frameworks, whether it's SpecKit, and there are others out there, but and I know Rahul's done a bit on the client side of baking off and seeing what more so what produces the best quality, right, Rahul? That's, I guess, a really big thing for us. Yes, there's, you can go faster and be more efficient, but at the end of the day, quality will be all. And then, those skills that interrogate the spec before anything else is nailed down. Awesome. Thanks, guys. I think the next question is pretty pertinent to that and is around context. And I guess two parts to this question. I suppose from my own personal perspective, we think that context is the asset, and the more AI knows about your business and your logic and requirements, the better. So you feed it everything will not necessarily, not just from a cost perspective, every piece of context is going to cost more on every single call. It's rent, for example, it's not a one-off purchase, but it could also make the output worse. And so that's one thing to consider. Also, we talk about this notion of evergreen content. And, if you have stale documentation that AI is pulling upon, well, that's when things can get pretty dangerous, because the AI is just going to trust what's there and steer confidently in the wrong direction. So I guess two parts to this question, Serge. How do you decide what goes into context, and how do you keep it evergreen? What do we mean by evergreen? It's not necessarily the foundational things. It's making sure it's always correct, right?
Absolutely. So I think, as you did say, Chris, we do want to be parsimonious with our context. We don't want to just throw everything in there for the sake of throwing things in. We need to have essentially a hierarchy of knowledge and documentation structured for discoverability. You don't want to actually load all of your possible documentation for every feature that you're creating in your product. You do want a core of universal cross-cutting documentation that should be applied everywhere to every problem and when doing anything. that's probably divided into, I would say, a product domain documentation and technical documentation is a reasonable split. So an example of a core product documentation is, as we got there, the glossary, the product domain language. When we talk about a customer in the context of our product, what exactly do we mean? We want that to always mean the same thing. I think between team members in the team, there is an understood context for when we say customer, this is what we mean. When we say vehicle, this is what we mean. When we say inventory, a very ambiguous term that's probably overloaded in a lot of domains, this is exactly what we mean. We want the agents to have access to exactly that level of understanding. Now, the second part of your question, evergreen, it's actually an ongoing concern. Documentation is not just write once. By evergreen, we mean that it is up to date. It is never stale. It is always relevant. And that's true of the core principles for both tech and domain, but also the domain-specific product and technical ideas that we've put in for some of our more edge case parts of the product. As soon as we have documentation that is incorrect, that does not reflect reality, then that's not just not as good, it's an active negative cost. And that can mean that the loop or the agentic workflow that you use just takes longer because it has to resolve conflicts. It can mean that the end result is not as good as it would otherwise have been. But either way, as we say on that second thread, it is an ongoing discipline. It has to be kept evergreen. It has to be kept up to date because as soon as it isn't, it's a net negative. Rahul, I think you had some thoughts on this as well.
Yeah, totally. I mean, just echoing on what Serge said. Also, just probably this goes back to the previous slide. The good thing is now, because people have been trying this for now, I'd say a couple of years, the frameworks themselves really do enable us to do a lot of this, the idea of keeping things evergreen, making sure all of the, let's call it the ontology map is up to date and the domain knowledge and whatnot. So I expect, for instance, you could have a constitution, you could have an agent.md file. And a lot of that is done for us through the framework that we'd use for the coding agents. And the other thing I'd say here, so to use a solid example from the current work we're doing, is the third one, challenge, don't just harness. So what we do is, let's say we're currently building a payment service, let's say. We're building an inventory service with our current client. And a part of this would be working with product, working with BAs, and trying to understand what we're trying to build for this given feature. And we put together a PRD, a product requirement document. And this PRD is very detailed as to what we're building. And then what we also do is we get Gemini to take notes of all of our meetings. So we'd have about 10 meetings. And then as we put together the PRD, and usually this is an engineer that's like the feature lead that does this, you can tell the agent, you can be very explicit, find gaps in terminology, find gaps in what does this concept mean, as Serge was saying, inventory, a very vague term, but in our specific org, what does that mean? And frankly, I've been really impressed with the newer models. It's ruthless. It's ruthless to a point where you've got to be like, okay, take it easy. It's too much grilling. I feel like I'm at a deposition, like, so.
now you've hurt my feelings.
Yeah, I'm getting offended. So you can tell it, ask me 5 questions for clarity. And then it'll also, in the PRD, it'll also, you can get it to create like a decision log, which kind of gives you a bit of context as to why a certain decision was made. And then the more kind of upfront work we do like that, the less time we spend, time and tokens and money we spend in the building phase. Because the issue is, if you give it, as Serge was saying, too much context or too much just like vague kind of, let's say, sentences, it'll make things up, it'll hallucinate. And then that's just going to create grief. So yeah, I just kind of want to talk about that last point, challenge, don't just harness there.
Yeah, I'm glad you did, because yeah, I know that models can affirm our framing for certain things, but we know that it's very important for context to include any forbidden patterns as well, right? Because we know you ask an LLM a question, it's probably going to say, "Oh yeah, good point, good answer." So yeah, those are the kind of again, what we pull upon is that glossary, that product domain language, and Serge, that's more schemas rather than code bases, right? When we come up with what we're pointing an LLM towards.
I mean, yes, it is. It's schemas, but it's also, what are the core concepts of my product? What is the language of my product? And Rahul used the term ontology, the ontology map. What are the things that must exist to make my product work as a product? And what do I mean when I talk about them? So yeah, that's nailing that down in very specific language is incredibly important. I will say that's not a new problem. The agents complicate that slightly, but it's always been a concern for teams to make sure that we don't confuse each other when we talk about what inventory. I want to add something to the inventory. Fine. What does inventory actually mean? We have a very specific meaning within our domain for inventory and all these other concerns. What does it mean for us?
Yeah, no, for sure. Thanks, guys. So question 3 around cost. So we know how powerful some of these frontier models are. You could put everyone on it. You could call that your AI strategy, but I don't think that's really going to work. But it kind of, yeah, connects back to when we talked about standardization. And if we've got a structured way of doing work upstream, then most of the downstream work is probably simple enough for cheaper models. And that expensive thinking has already happened. But I think there's a timing issue here. We know that current AI pricing is a bit of a land grab, and things are going to change pretty soon. So the organizations that build the ability to swap models per task will ride that. And the ones married to a single vendor will probably wear it. So probably one for Rahul to kick off with. When is a frontier model worth it? And is other ways to know when you're overspending on something?
Yeah, I mean, it's hard for me to like be prescriptive about this, but like just from my experience, I'd say I've never used any of the frontier models for like day-to-day coding work. It's just not worth the token costs. For sure, I think the part where I was kind of talking about the PRD and the product kind of requirements gathering process. For that process, I do use somewhat of a higher model. Usually it would be something like Opus 4.8 or not even like Fable or anything, but something like that, or from GPT, maybe 5.5. And that's more just to make sure, that again, those kind of ambiguities are fleshed out, that there's no, again, business domain knowledge that isn't unclear when we're in the build phase. But when it comes to the coding agent, so right now, what I've been using is GPT 5.6 Terra. I mean, these things, again, the specifics don't really matter. It's more, Terra isn't the frontier model. It's not the most expensive model. And I've found at least, is quite token efficient. But the reason I think a lot of the newer models, that you don't need the frontier models, is because there are all the harnesses put around them to ensure that they write good code. So there's the harnesses that the AI labs themselves build, but also the harnesses we as like AI engineers also build for them. So which is here, things like static analysis, the CI tools, and then also giving it access through via an MCP server, or sometimes just plain old CLI tools, because MCP servers can be quite expensive, token wise, to the internal GitHub repo and other parts of the code. So I'd say for sure you really need the frontier model for like day-to-day coding with what we currently got. But I don't know, Serge, if you beg to differ.
No, I'm broadly in agreement. I think where those frontier models can add value is at the specification stage, where essentially you're there to resolve ambiguity, to build up the shape of what needs to be built. But when it comes time to do the implementation, that should be a mechanical, or at least relatively mechanical process. One of the important concepts, I believe, for this type of multi-phase agentic workflow is the notion of boundary artifacts. So the specification stage produces a specification. The plan stage takes that specification, the output of the previous stage, as the input of its work, along with any context that you add to that stage, and then produces a plan. And then tasks take that plan, break it down to tasks. Again, each boundary artifact output being the input to the next phase. And at each point, what we're doing is we're building up a plan, we're resolving ambiguity, so that by the time the implementation phase comes along, you've got the exact lists of tasks, you've got exactly the technical plan for approaching it, you've got all the reasoning, the business reasoning behind that plan, although the implementation should not need any of that context. It should work pretty much solely on the boundary artifact produced by the phase before it. And then that is a mechanical process. You certainly don't need a frontier model for that. You may not even need a remote model at all. One of the things that we think might be an increasing trend in we've said the next 5 years, but I actually think it might end up being a lot earlier than that, is the use of cheap locally running models to do implementation. If you don't need that powerful frontier model to do it, what you want to do is to optimize for price. In fact, these frontier models can actually be less efficient, not just in terms of token usage, but in terms of time for these mechanical tasks, because they essentially overthink, course correct, self-reflect, rerun concepts when they don't need to. There are no traps, there are no hidden ambiguities here, because we've resolved all of those in the previous stages. What we just need now is a cheap model that is good at implementing and that just goes and does it.
And just on that point there, static analysis, so there are heaps of tools where you could kind of get the agent to work with. So solid example, I'm not going to mention the tool only because it's open source, and recently we found that it's not being maintained anymore. Therefore, it's a bit of a security issue. But there's a tool which kind of gives the code base on overall score based on things like modularity, mutation testing, how many tests are there, and whatnot. And you could guide the agent to say, okay, until the score from this tool is, you give it a threshold above 80, you can't commit this code because there's something wrong with the, with whatever that's going on. And frankly, in the past month or so, it's been following those instructions quite well. So it's the tools themselves can be used by humans, of course, to verify what's being built. But at the same time, well, firstly, I believe at least engineers should read their code. So you read your code, that's one thing. But also you use these tools. But at the same time, you could get the agent to use those tools themselves to kind of reflect on what, so as it were, on what they're building.
Yeah, absolutely. We won't deep dive too much into this because I know we've got a couple more questions to go into. But it's actually, I think, a really important broader point, Rahul, that you've just made. For some of these problems that we want to have, attack, agents may not actually be the best tool to reach for. You don't always need to reach for an agent to give your code base a score. There are existing deterministic tools that are faster, certainly much cheaper. And I think part of building up that harness is finding the right tool for the job. If it's a deterministic task, use a deterministic tool. There's no need to use agents for everything.
No, couldn't agree more. And I think it, comes back to that question about model usage and selection. It's about finding the right model for the right job. And, we're talking about how we apply AI to engineering here, but even some of the work we've been doing for, customer experience solutions or internal efficiency solutions. A lot of the time when we start a conversation and it's about how can we apply AI to this problem, and we get into the weeds of it, it's, well, this is a traditional machine learning problem, or this is a optimization problem. And the board might not be happy that you're not going to be going down the AI path, but the most important thing is we're solving the problem the right way and building the right thing. So yeah, thanks for touching on that, guys. So a couple more. I want to get ahead of myself there. So question 4, what does a safe, recoverable AI loop look like, and what's your ripcord? So I think the thought of running AI unattended for hours, on the surface sounds kind of quite outrageous and somewhat irresponsible. But again, we've seen patterns like this before. So when engineers first wanted to deploy code to production multiple times a day, we found ways to ensure there was engineering rigor there. There were tests and rollbacks, those controls baked into the process. And AI is no different. We just need to add controls in different ways. So we look at it like a car. The brakes don't make a car go slow, but they make going fast a lot safer. So Serge, if we're going to go and trust a loop that, say, runs on hours unattended, what are the brakes we're using? How can we make sure there's controls?
Referring to your idea about CI/CD and pipelines and how they gave us the confidence to deploy to production multiple times in a day, that's essentially what we build up with our harness engineering, with our loop engineering. It's confidence in the process that we've created. There are all types of controls and mitigants that we can put in place when running a loop from end to end. So sandboxing, to have absolute bounded permissions on what agents can actually do and what they can access. Strong orchestration. Orchestration, I don't just mean proper handover, but boundary checking. So that first phase, it should produce exactly this type of artifact, and we can interrogate that artifact to see if it passes what we would expect out of it. Some that can be agentic, some that can be deterministic. Telemetry also is an important part of that orchestration layer. So we want telemetry not just for engineers overseeing a particular loop run, but also so that we can centralize our observability across all of these agentic runs and see trends. So what's agentic engineering actually costing us? How does that relate to the features we've actually put into production? If we tweak our settings or our context or our skills, what type of measurable impact does that have on what we're doing? And as well as that, we actually need not just insight into the loop, but a way for the loop itself and us as overseers to be able to say, well, you need to stop now. This isn't working. And you need to give me, as the overseeing engineer, enough information so that I can diagnose what's wrong and feed fixes back into the harness, the loop, and the orchestrator. So, as we say here, human judgment is applied once over those escalations that we've found. These are the failure points, the breakage points for the loop, and then codified back into the loop itself in the form of changes to the context, changes to the skills, or even changes to the overall orchestrator. So that oversized PR, ideally, we don't want that to be just things that happen every time we have to accept. We have a very specific outcome, a very reproducible outcome in mind for this loop. And over time, we will tune the loop so that we get closer and closer. And that's the process of building up confidence in the loop.
Yeah, excellent. Anything to add on that one, Rahul?
No, nothing really, apart from maybe something, Serge, you said when you were one of our many nerd chats, yeah, I mean, look, all that one slide that you showed, Chris, it kind of made it implied that it's like a linear process from like context, harness to loop engineering. It's probably better, in my view, seeing it that they're more like cousins. So, not all services are the same. Like, for instance, I don't know, like some front end login page probably it's fine to have a loop or it being loop engineered, whereas you have a payments gateway that probably requires deployments to that service probably requires a human in the loop. And that's where you need to kind of think about, okay, AI safety and maybe some kind of protocol which involves the final decision being made by a human before deployment. So yeah, the TLDR would be, yes, where possible, codify context back into the code base, all of that, create loops, but at the same time, understand the kind of the business use of the variety of microservices that an org uses. And I think that's quite important because like it's just it's not like one size fits all is sort of what I'm trying to say here.
It's actually two really good points there, Rahul. Firstly, not all problems are the same in terms of danger and blast radius. And secondly, and something that is still true regardless of how many agents you have running, regardless of your tooling and orchestration, which is that we as engineers must ultimately be accountable for these.
Correct.
100%. Cool. Well, we'll move on to our final question. Just a reminder, if there's any questions from our audience, feel free to drop them in the Q&A. And if not, we can answer questions offline as well. And then there's nothing else, we can also wrap for an early lunch. But we'll tackle this final question. How do you measure whether a change is actually an improvement? So I think early in the presentation, there was a statistic that 95% of pilots have no measurable impact. Now, I don't see that as AI doesn't work. I read it more as, well, nobody defined what impact would look like before they started. And even from an engineering point of view, we've heard stories of, teams using usage and tokens as a badge of honor, and it's not how we want to kind of measure things. And look, you could measure the model instead of the workflow and get into lots of problems. So I think, the unit that matters is the loop end to end. What did it cost to ship features? How long did it take? Did it survive contact production? That kind of thing. So probably one for Serge to kick off with. How do we get to a point where we know AI is working for us and we're measuring the right things and we're actually gaining traction where we need to see it?
Well, I think these are not new ideas. We've, as engineers, as product teams, this is an ongoing struggle for everyone. How do we measure how effective our product team is? And there are already measures in place, metrics for exactly this type of thing. I mean, you can look at DORA, you can look at space, you can bring in the idea of velocity. It's really just adding another dimension to these metrics, which is, okay, and in terms of AI spend, in terms of tokens, how much did that cost? And are the trends heading in the right direction? Ideally, what should be happening is that you get more and more efficient at using the resources to achieve your goals. So is our ability to deliver accelerating? Are our AI costs going in the right direction, or at least holding steady? And is that worth it? That's fundamentally the question we want to ask and answer is what we're spending on AI giving us the type of return on investment that we want? So as we're saying here, we want some metrics so that we can have a defensible AI spend. We want to benchmark the entire loop end to end, not isolated parts of it. And ideally, we want to tie our benchmarks to a concrete business goal. So if our business goal is develop the ability to deploy an internationalized version of our product to a new country within 4 weeks. Let's make that an official goal for this. And are we trending in the right direction to get close to that goal or not? Again, these are not fundamentally new ideas. It's a new spin on an age-old problem.
No, definitely. Rahul, thoughts on that one?
No, I mean, I've got nothing more to add, apart from maybe I would say certainly what not to do is to do so-called token maxing, which is just spending as many tokens as possible, which I find to be asinine. I mean, the way I think about it is like, I mean, I'm a DS employee. If I irrationally cost the company more money, that probably makes me a bad employee. So token maxing is probably not the best way to go at it, especially with now how recently the big AI labs have changed their pricing models. So yeah, as Serge was saying, I think it's just kind of, it's an ongoing, almost like an empirical process where we figure out what's worth measuring, and seeing what are the tangible outcomes.
Yeah, and iteratively, do our changes to the product, to the harness around it, to our agentic workflows, do they move us in the right direction according to those metrics that we care about, or do they not? And this is a process that is not new for any of us. It's the same foundational ideas behind iterative agile improvement.
Yeah. Or like, for instance, at most companies, DevOps teams, they usually have like a FinOps team, right? So the cloud costs, if you're using AWS or GCP, whatever, we have to justify why we use a particular database or however we do the scaling. The same philosophy applies to how we utilize these AI models too.
Yeah,
absolutely. And just to the just to what Rahul brought up around token maxing and token leaderboard, I think they're kind of a relic of when people weren't so much measuring AI productivity and efficiency, more just measuring AI enthusiasm.
Yeah.
Employees. But yeah, it is absolutely a ridiculous metric. I completely agree.
Yeah. No, I couldn't agree more. So we've had a couple of questions, which is great, and we should have time to answer both of them. So thanks, Danielle, familiar name for you, Serge. So how are you seeing teams evolve in terms of roles in this new world? I find this one fascinating because of where the changes that are happening to the software development lifecycle, AI, DLC, where bottlenecks are becoming more prevalent, how different roles from design, product, engineering are using the tools. I think we'll see a big change, but yeah, interesting to hear what Serge and Rahul are seeing on the ground.
Firstly, hi, Danny. Secondly, it's a really interesting question. What I am seeing happening currently is that those roles are almost getting a little bit more porous in terms of responsibilities. I think engineers and UX and product owners, it's more that they're champions of different aspects of the product. So the engineers, they are champions of technical quality, but they also have to pay attention to the other aspects of the product. The product owners, champions of the product viability, and UXers, champions of the customer in relationship to the product. But those roles are, as I said, porous. You have to take a broader view across the product lifecycle as an engineer. You're not just head deep in code. You're representing code quality in the entire process, end to end. I also think that I think there's a bit of a feeling that AI and structured prompt development workflows reduce the need for collaboration, and I absolutely disagree with that. If anything, it increases the need for collaboration. And at these points where we define, that spec for a particular feature, those are perfect collaboration points. for team members representing the three lenses of a product. So bring the engineer, bring the designer, bring the product owner, and have them collaborate around defining exactly what we want out of this feature. The engineer can then take the process after that through the technical plan, through the implementation. But it's an incredibly important collaboration point to get everyone aligned and on board with what exactly we're trying to do.
Yeah. Serge. Rahul, any thoughts on whether roles are simply evolving, or do you see new roles coming up? What's your take on it?
Yeah, I mean, I love this question because firstly, the whole team management roles, I'll just say humbly above my pay grade. I don't really deal at that level yet. But if I may say, just from a lived experience point of view for engineers, I love what all of this AI stuff has done, because as Serge was saying, it used to be where whoever your manager gives you a Jira ticket, work on this, and you're like a code monkey typing away code, right? Which is fine. I like writing code, but the best part of, I think, software engineering with time is, in fact, kind of knowing what you're building and seeing who benefits from what you're building. And so when we collaborate with designers, PMs early on and build this kind of shared understanding, that understanding persists throughout the project. So it's not like, so let's say we work on a 2-week sprint, sometimes longer. And whatever the shared understanding that, for me as an engineer, I gain about what we're building, that it lasts throughout the project. And then you kind of compound on that, and you kind of get a better understanding of your project, of your product and what you're building. And so rarely do I feel siloed and lacking context. And here I would say, if an engineer is feeling like that, that's probably a toxic team. Like, you probably should speak to your leaders and be like, hey, I'd like to get involved with the PRD sessions, or with the kind of the product discovery sessions early on. So for me, I've just seen like a lot of pluses. And I would say, though, just not as a negative, but perhaps where things probably can change, this kind of model of kind of in Agile, where we have like stand-ups every single day, and then retro, all of these, those rituals may have to change a bit with time, because I don't really see this whole thing where here's a Jira ticket on your board, and now give me an update on what you're doing. I'm not sure if that's the best approach to go with this kind of way of doing things. That being said, though, in terms of like the lived experience, it's great. Like, I'm loving the actually working with PMs and designers on what we're working on.
Just to your point, your last point there, Rahul, I agree that, talking about your Jira ticket maybe isn't the most useful thing we can do, but I do think that having regular touch points that bring a team together just to summarize what's happening, to understand what other people are doing and going through, that's still an incredibly valuable part of the standard team rituals. But yes, absolutely. It's one of the most, I think, satisfying things about the impact that AI has had on the engineering role is that you're not quite as much just in your own little box, being the robot that takes the ticket,
the code monkey,
that pushes it on. Exactly. And I think it's interesting because this is part of a larger long-term trend that I think you especially see among consulting engineers, but it's also true of product engineers, where product engineers have to take ownership of more of that process end to end. Because software engineering is a team sport. It's not enough to just be a code monkey, as you said, Rahul, in the corner typing away. What you need to do is you're bringing a specialized point of view and knowledge to the problem of how do we make this product good? How do we have an effective product? The end result, the goal of what an engineer does is not to create code. We don't just code for its own sake. We code because that is the way that we translate ideas into business value, into something that is useful for our customers, into something that is valuable for our customers. It's not just technology for the sake of technology.
Exactly right. I only thought we had one more question, but we've got heaps more. I wasn't paying close enough attention, so maybe we can answer some of those offline. One I did want to get to from Drew. Good to see you. I think this is more in relation to greenfield builds, but when it comes to tooling to wrap around the development lifecycle, are there anything we would recommend to adopt? In particular, Rahul, yourself?
Yeah, I mean, for sure. I mean, SpecKit is one tool that we've been using quite heavily as a framework. But then this other tool, the reason I don't want to mention is because we just found out last week that it's not being maintained anymore by it's an open source tool. So I'm not sure whether it's safe to use. But yeah, like, things like SonarQube, a bunch of static code analysis tools are available. And then on top of that, it's also, I mean, you could, in a way, create your own tools internally, like through like shell scripts and whatnot. You don't really have to always rely on, what's like paid tools or what's out in the market. Like, that's, again, one thing with these AI agents. It makes, if you want to build like a handy little script, it's really quick because you don't have to like hand write that code. Yeah, I mean, I'd say that. I was going to mention another tool that just I've just lost it. But there are those tools, but also then in the CI/CD process, just making sure, like, we pay attention to, that really this is like, old school software engineering 101. Like, there's proper testing. It goes through some kind of like smoke tests and browser tests. Those things are really important too. Yeah, I mean, that's probably all I can talk about at the moment, at least confidently. Oh, sorry, just one more thing. I've been playing around with this, haven't used it in any client projects, is like these LLM graphs. So they're like, you can use them. What's this? If you Google just LLM graphs opens, it'll come up. This is just to be a bit more token efficient. So the idea is you create like a knowledge graph for the agent to utilize when exploring a new code base, so that it doesn't have to like read heaps and heaps of let's say Java or C# code, because that's going to cost, again, tokens, right? So that's maybe from a cost side of things pretty useful too.
No. I definitely, and I know we're running out of time, Chris, so I can feel you glaring at me. But very quickly, just to Rahul's point, I think a lot of this tooling can be built up over time. It's important, I think, to just grab a framework that appeals to you to start off with. So start with SpecKit, start with, there's a number of others, and see how it actually feels as a team. Does your process inherently not quite match this? All of these frameworks are extensible. They can be tuned for exactly how you want to approach this, but start with something relatively standard and evolve it over time.
Yeah, I'd go with that as well. No, awesome, thank you. There are a couple more questions. Sorry we didn't get to answer them on this session, but we'll make sure we ask Serge and Rahul for their thoughts and get it to you offline. Or Danny, I'm sure Serge would want to meet up for breakfast or coffee again. He can answer it in person. But yeah, we'll wrap it up there. Just another thank you for attending. Thanks for your questions. Anything you need from us, the slide pack, the recording, we'll get that over to you. Happy to have conversations as a follow-up as well. But no, thanks for your time. Thanks, Serge and Rahul. And hey, maybe the next one will be more of the roles and the remits of people, because I feel like that's one that we're going to see change a lot as well. So yeah, thanks again, because we might use that as an inspiration for the next one. But thanks again, and yeah, we'll see you all next time.
Thanks for having us, folks.
Thanks, everyone. See ya.
Cheers.